Welcome back, everybody. We are to chapter 10, part 1. And chapter 10 is all about correlation and regression. And just real briefly, sort of an overview. A correlation is a connection between two things, like a real connection, a demonstrable connection. And that's what we're going to focus on a bit today. The second part, which will be the next video, is all about once we've established that there is or is not a correlation, then what do we do? How do we predict things, which is what this chapter is all about. So a correlation exists between two variables when the values of one variable are somehow associated with the values of another variable. When there is a correlation in the plotted points of paired data, the graph can be approximated by a straight line called a linear correlation line. Correlation. And I have some graphics here for us, and we can kind of see that it's not perfectly linear, but we could sort of come up with a line that's sort of indicating, it's supposed to be a straight line, that's sort of indicating as a representation for that. And here you can see there is no correlation at all, certainly not a linear one. Here there's not a linear correlation, but there's a parabolic correlation. And there are lots of different types. We're only going to focus on linear correlations for chapter 10, for this course. Now I want to point out, we have something called the linear correlation coefficient, represented by R, and it measures the strength of the linear correlation between the paired quantitative X and Y values in a sample. So you can see here R, by the way, just some quick properties about, this is how you calculate it, which we won't do. Our calculator does all that for us. And some notation, R is the sample linear correlation coefficient, and rho is a Greek letter R, is the true linear correlation coefficient for the entire population. And some properties about R, it's always between -1 and 1. And R measures the strength of the linear relationship. The closer to -1 or 1, the stronger the correlation relationship. And the closer R is to 0, the weaker the relationship. So let me go back to these pictures real quick. And you can see R is 0.8. And you can see that 0.8, that's pretty close to 1. So you can kind of see a linear correlation. Here it's -0.965. That means there's a really strong linear correlation. And the reason that we would want a linear correlation is we can then predict, you give me an X value and I'll use the line to predict what that Y value will be. And so the tighter the grouping, the better the predictor. This is called a negative correlation because the slope is negative. This is a positive correlation because the slope is positive. Let's do some examples. Example 1, find the value of the linear correlation coefficient for the paired shoe print. Actually, before we do that, I want to draw a little bit of a picture for us. So when we have the graph of R, this is R, and this is going to be at -1, this will be at 1, and this is at 0. Remember, the strongest linear correlations are when we are at the ends like this. What we're going to do is we're going to be able to come up with some critical values that give us cutoffs. So for in between here, then there is no correlation. But if we're between this barrier and -1 or this barrier and 1, then we have a correlation. Here or here. All right, so now let's go to our example. Here we are. So we have shoe print size, this is in centimeters, and height, also in centimeters. And so we want to know, is there a linear correlation? So let's do this before we run anything. This is R, -1 to 1. 0 in the middle, and we got to find our critical values. To do that, we're going to use 0.05 and N in this case is 1, 2, 3, 4, 5. So here is a table that's with all the other tables that you have that's in Canvas. And N is 5, and we're at 0.05. So our barrier here is 0.878. So our critical value is 0.878. Close. So there it is. And so again, if we're in between, no correlation. If we're between here and here, or between here and here, there is a linear correlation. I've previously put these into my calculator. You may need to pause the video to do that. Let me show you. So you can see 29.7 and 175.3 and so on. So I'm going to be L1 and L2. And we are going to run lin reg t-test. I believe that's what it's called. Let's check it. It's all the way at the bottom, so I'm going to hit up. You can scroll down if you need to. Linear regression t-test. There it is. And my X list, my shoe print, that's an L1 for me. And the height is in L2. Oh, I forgot to put our hypothesis. So here's our null hypothesis is that rho equals 0. And alternatively, rho is not equal to 0. And if rho is equal to 0, then there is no correlation. If it's not equal to 0, that implies that there's a correlation. All right, so let's run our test. And you'll notice it's a not equal to here. So we're good. And we hit go. And we scroll down to find R, which is what they're asking us to find. So R in this case is 0.59. We'll just stop there, 0.59. And you can see we are in the non-correlation zone. So we are about right here. So no linear correlation between shoe size and height. And is there sufficient evidence to support the claim that there is not a linear correlation? So we are going to fail to reject. The null hypothesis, meaning we think that there's no linear correlation. So there is not sufficient evidence to support the claim that there is a linear correlation. All right, let's move on to the next example. And I have previously put this data into my calculator. This is, for me, this is list 3 and list 4. You can clear out your list 1 and 2 and re-put these in or whatever you need to do, but you may need to stop the video and do that. Listed below are PSAT scores and SAT scores from prospective college applicants. Is there sufficient evidence to conclude that there's a linear correlation between PSAT, I misspelled that, and SAT? So we have, once again, we're going to assume that there's no linear correlation. There's a claim that there is a linear correlation. So let's run. Let's set up our little table again here. -1, 1, 0. And in this case, we have 1, 2, 3, 4, 5, 6, 7, 8. So n is 8 in this case. And alpha is 0.05. So 8 and 0.05 brings us to 0.707. So that's here. So here's the no-go zone, and here's the. All right, let's get R. Let's see what we got. Stat tests, linear regression t-test, and mine's an L. Let me remind you how to do that. Mine's an L3, so second L3, and L4, second L4. There we go. And get that R is here, 0.54. So R is 0.54. So once again, we're in the no correlation zone. So that's over here. So we are going to fail to reject. The null hypothesis. So there is not sufficient evidence to support the claim that there is a linear correlation. All right, so we have 2 strikeouts so far as there being a linear correlation. So PSAT scores have don't seem to have too much to do with SAT scores. And I read a study that said if you study how to do SAT, you'll do well. That doesn't mean that you can carry that skill to something else necessarily. All right, last example. Listed below are among of court fine revenues and salaries paid to the town justices. All amounts are in thousands of dollars. Is there sufficient evidence to conclude that there is a linear correlation between court incomes and justice salaries? So again, I've already put this into my calculator. This is L5 and L6. So you may need to pause this to do that. But let's put down our hypotheses. And let's get our critical values. And 0 in the middle. In this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And 0.05 again. So we are at 9 and 0.05. That's 0.666. So that's going to be and 0.666. All right, so once again, if we're between these two, no linear correlation. If we are between these numbers and the 1 or -1, then there is a linear correlation. So let's see what we got. So once again, stat, tests, linear regression t-test. I'm now at 5 and 6. So here's L5, second L5, second L6. Calculate. And let's see, R. Ooh, got something interesting here. So it looks like R is about 0.864. Hey, That's about right there. So there's linear correlation. So we're going to reject the null hypothesis. So there is sufficient evidence to support the claim that there's a connection between court income and justice salary. Now, what comes next, the next section, the next video is, okay, so now there's linear correlation. Now what? Who cares? What can we do with that? So that's coming up.